3. Yeah, it's worth 10 marks. So it's worth 10 out of 60. So you can't lose that free 10 out of 60. So yeah. And you notice something here, right? They tell you that it has a, they didn't tell you which specific one. So it can either be a okay, recording has started. It can either be a aggregation or composition. It doesn't matter. They just mark for has a relationship because you understand that one thing is contained within another thing. So basically, you're a person, which is a class. So that means you can create a person class, and that person has a heart. A heart is its own object or its own class. So therefore, that would be a has a relationship. It's unlike C++, whereby you need to actually denote whether it's aggregation or composition. With Java, you can they can let it slide. They don't really care about it that much because they know you understand it. You did it in ComSci 1B. So let's start to the UML. Let me open my Eclipse. You basically do UML based on how you've named your variables and your functions in your code. So when you do UML, you have to go actually look at your code, not the PDF. I know the PDF has some information, but you don't look at the PDF, you look at your code because UML represents what you've written. To be honest, it should actually be vice versa. You should actually start with the UML. But then I would advise you do that, use that technique if you're a pro. You read the textbook and you've practiced, maybe you've been doing past papers every day. And all your past papers all of your past papers that you've done, they always run. So those are the people who can start with the UML. But if you're taking a bit, try starting with the actual code, even though it's actually the opposite order. When you go to the industry, you start with the design. So let's wait for Eclipse. Eclipse is always something, is always acting up. I don't know why it's taking so long. Let's wait. Come on, Eclipse. Yeah, this thing takes its time. So there's the program I'm gonna need to. Yeah, one thing right about. You see how many classes that are here. People think when I say we're only doing UML, I'm just joking around. There's a lot to do here. You see, there's different packages, and you need to use that technique of different packages. So I need to actually use Dia. Do I have Dia? Let me double check. Oh, I almost thought I didn't have. I was like, yo, that's gonna waste time having to download it. So what I would do, right? It's up to you what order you start in, but what I would do is I'll start with main, right? And notice something, it's in the default package. It's still in a package, but it's the default package, right? Then you're gonna make sure you choose here an option for UML because you're doing unified modeling. You're doing a diagram using unified modeling language, which is UML language. Excuse me. So you're gonna choose the symbol for package. There's large package and small package. You'd always choose the large package. Yeah, you always choose the large package. So let's just choose the large package. Then you can stretch it out, right, a little bit. Then I'll just put it on the side. Then double click. If you want to name the package, right, double click on it. Then the name is default, right? Because the default, that's what it's written in the practical, in your code. It's in the default package. So therefore, I'm gonna name it default. Then I need to place the main class. So to be honest, the main class part will be the easiest one because it's short. So the class name is main, and then the attributes, it has no attributes. By attributes, right, they mean the instance variables. The main class, does it have one? No, it doesn't. But it has one thing, which is a main function. So it has a function. So we need to put that function. It's called main, and it takes in an array of strings and it returns void. So I'm gonna go to operations, new, and don't put constructor because you saw that there's no constructor. So don't only put the things that are there. So the name of this function is called main, and it returns the return type. The type means return, what's being returned. It's a void. Then inheritance type, right? Leave, it's basically whether it's polymorphic or abstract. It's not an abstract method, so I don't have to choose abstract. It's not an abstract method. But if it was an abstract method, you choose abstract there. Then there's something that we call class scope, meaning, remember we talked about static, that it's part of the class. It doesn't belong to an instance. So this is where you choose click class scope to make it a static method. Remember, it's a static method, so I'm going to choose class scope. Then it is a parameter, which is, what is the parameter's name? Is called args for command line arguments. And this type or data type, it's array of string. And then apply, and then you're done. Click OK. There's my main class. It's inside the default package. Since it's my main class is actually quite small, I don't have to make my package that big. Yeah, so yeah, let me leave it like that. So there's the main class and it's inside the default package. That's the part I don't like about UML, especially in question one. There's quite a lot of diagrams and all those unnecessary things and packages. So yeah, packages, they ruin everything, as you can see. And then I need to grab another large package, double click on the package, give it a name. So which package am I going with now? I'm going with the axi.file package. So let me go into this, copy this name because that's the name of that package. So copy, go to dir, paste it here under name, and then apply, and then OK. So I've given the package a name. Then I need to stretch it out because I'm going to have a class there. Since there's one class, so it won't be that big. But you notice that other ones become very big. So I'm gonna not double click, drag and drop a class. There's a class, double click. Remember that class, the class we're about to create, we need to create a class that's inside the package. So the one that's inside the package is called reduction area file handler. So I take that, I say I replace here and put the name there. Then under attributes, do we have attributes? If you check here, we do have. By attributes, they mean variables, whether that's class or instance variables, meaning static or not static, as long as they are variables. In this case, we have static ones, which are class variables. So we need to also declare them in our UML. So we have passive pattern. I'm going to start with that. Yeah, okay, it's fine. Yeah, this is it's quite annoying. It's quite annoying. So you'll see how annoying this thing is. So we have static. It needs to be static and it's final. It's a constant. So I'll copy that name under attributes, click new and paste. And then its type, it's of type pattern, right? It's an instance of the pattern class. Its value, basically, what is it initialized to? It's actually initialized to pattern.compile. So I'll just write this. I don't think you have to write this, right? But then it's fine. You could, okay, it's not actually, the thing is, if I only copy the regular expression, right? It's gonna be like, maybe it's of type string, of which is not a string. It's of type pattern. So I just have to write that full function there. Then paste, you see that, because that's what it's initialized to. Notice something, the moment I press apply, notice that it's gonna say equals to. So apply, you see, equals to, because that's how it is in my code. It is equals to pattern.compile. But then I'm not done, I didn't make it static. And if you look at my code, let me show you something. If you don't put in a modifier, right, an accessor modifier, basically public, private, protected, or package. Remember, package is also a modifier. So public, private, package, whatever. If you don't put a modifier, by default, it's package, private. So when I go here, I'm gonna choose there should be package, private, or package, but then in this case, it's not there. Let me see what implementation means. I don't know. Maybe implementation is the one that means package, but I don't see it. But yeah, I don't see it. So let's leave it to public. It's fine. Let's leave it to public. Remember, dir is not specialized for Java. It's only for diagrams. That's it. So it doesn't care whether protected. It doesn't know about that. For package, that's only a Java thing. And then since it's static, I'm gonna choose class scope. Make sure I tick class scope and then apply. I'm not done yet. I'm just applying. Don't click OK, because if you click OK, see what happens? It closes it. I don't want to close it. I want to apply my changes. So that's why I'm gonna keep clicking apply. after I've added something new. So I'm going to add a new variable called active pattern. And then that's the name. So paste active pattern here. It's of type pattern. And then its value, what is it initialized to? Basically, what is after the equal sign? It's basically this whole thing. So I'm going to copy this whole thing over here, which is a pattern or my regular expression. Then I go here, I paste it to be that value. You can put comments, right? You don't have to do that. I won't do that. I won't put comments. Then say class scope, click apply, then go to operations, right? So my operations is basically methods. In this case, I have one method, which is read block schedule. It returns a block schedule and it takes in a file handle. And it's static. That's something basically it's class scope. Excuse me. So new, and then it's called read block schedule, which returns a block schedule, right? And then it takes a parameter of file handle, which is of type file. So the variable is called handle and it's of type file. Then we need to make it class scope, meaning static, and then apply. And then I'm done with that function. Then I need to resize. You see why I said we're only gonna do UML today, because there's quite a lot involved in this thing. You might take it lightly, but there's quite a lot involved. So let me expand this. You see, I need to stretch it again. Yeah, I also don't know how they expect you to do all of this within that allocated time. Don't ask me, ask your lecturers. So yeah, that's the file. That's the class. It is as a block schedule, right? But then if you notice something, if you are using the type block schedule and it's not you haven't created a variable for it here, right? It means that that class is associated with the block schedule. So the relationship would be association. And we can represent that with that symbol. We'll get to that. We'll get to this arrows after, right? So remember, I have another third package, which is the municipal.model. So we need to create that package. Yeah, now the big problem comes. All those classes. Yeah, there's quite a lot of classes inside this package. We also have enums, blah, blah, blah. Hey, there's quite a lot. So copy this, and we have accessors and getters. And a toString, quite annoying. But then let's do it and the construct. So I'm gonna have active area, but before I do that, let me add the package first. So add a large package, double click, give it a name, paste, apply, okay. Then there's the other package. It's up to you where you place it. I would just place it underneath these ones. Oh, my thing's almost disappearing now. This package stuff is really such a drag. Um, Let me see. Yeah. So let's go to our thingy. So let me go back here. Yeah, wait, let's start with the base class. Remember, we have reduction area, which is the base class. So let's start with that base class first. Okay, let me check the question. I'm sure someone's asking a question here. Sorry to go off topic. With regular expression patterns, when catering for the white spaces, do you recommend? No, backslash T plus, it means it's multiple tabs, which is not what you intend. For catering specifically white spaces, meaning it's either one space or eight or a tab, anything that counts as a space. That's when you use the backslash S plus. So that if it says white spaces, you use the backslash plus, not the backslash T. Backslash T is specifically when you have a tab. If they didn't tell you that it's specifically a tab, don't do that. So I'm gonna copy this name of this class. And I'm gonna drag and drop the class inside here, right? So we have a base class, which is going to be at the top of our inheritance hierarchy, right? So I'll just put it there at the top. There's the name. I hope that answers your question. Then we have, they are protected. You see, you'll notice why I use protected, because in Java or in the UML, you're trying to demonstrate that you know a lot, as much as you can about the UML. Basically, you know protected, you know private, you know public, you know abstract, you know all those things. Let me just double check. Oh yeah, okay, that's good. Yeah, don't use backslash T. Backslash T is for when they tell you it's a tab. To be honest, again, I want you to go test that out now. Backslash T is still a space. So you can actually technically just replace backslash T with backslash S plus. Because remember, a tab, right, or backslash T is basically equal to multiple spaces. Let's say this is the string. If it's multiple spaces like this, it's listen to the terminology I'm using. It's multiple white spaces. Multiple, meaning one or more. So you can actually represent this as just backslash S plus. I use the tab because there's actually a tab. You can actually specify that it is a tab, but it will still work if you say backslash S plus. So we have okay, we have instance variables, right? I need to store the area ID, which and both of them are strings, area ID and word. So paste here, it's of type string, and they said it's protected, right? Protected, not class scope because it's not static. It's not static. And then the next one we have the word, which is of type string, which is also protected, and then apply. So they want to see this UML terminal symbol, right? Hash, minus, plus to show them that you really know you understood Java this semester. That's all they want to know. That's why I always advise you to make all your base classes instance variables protected so that when you do your UML, you demonstrate also that you also know there's something called protected. And then we have a constructor. So let's create that. Remember, constructor, we said that it's somewhat of a function. So that's why it will always be under operation. It's a special case of a function. And it doesn't return anything. Don't forget that. Even void, don't even void is not allowed there. Before we continue, let's go to class here. Click class here. Remember, they say the class is abstract. You choose the option abstract. So click abstract because the class is abstract. And this is the only time we do the UML. I will never do the UML again. Tomorrow at 8 again, we're gonna do one question paper 2. So I advise you go and write the solution for that. So let's create the constructor. We have this, and then it takes in two parameters, which is the area ID and the word. So it takes in area ID, which is of type. Type means it's the data type. Data type is what? String. If it has a default value, you can do that. Remember, parameters can also take default values. You see, if it had, in this case, it doesn't have, so we're not going to do that. So I'm going to click my parameters section here, select the parameter, remove that default value. Then click new to create a new parameter because there's two parameters. The second one is the word and is of type string. And then apply. And then I'm done with okay, not done. It's incorrect. It's not public, it's protected. Remember. So visibility will be changed to protected. Apply. Because that's what my code says. That's why I'm looking at my code when I'm doing the UML, because I'm basically showing my code in terms of diagram forms, in terms of a diagram form. So that's why I look at my code when I'm doing the UML. Then we need to get area ID. You need to name them exactly the way you've named it in your Java project. That's why I'm taking a careful look at them, but I understand what's needed. And so we need to create accessors and mutators for both instance variables. So let's start with the area ID. So we're going to start with the accessor. So get area ID, which return the string. Then we're going to have set area ID, which returns a void, and it takes in the area ID, which is of type string, that we want to set the instance variable area ID to. Then we have get word, right, which returns the string. Then set word, so set word, which returns a void, just like the void that Prudence always talks about when your card declines. Set word, yeah, perfect. Then the last thing that we need is a toString method. So toString method, which returns a string representation of the object, basically a string data type. Then apply, and okay. Then that's my base class. So this is everything about my base class. So let me position it properly, put it somewhere in the middle there. You know, these classes are going to be quite big. You notice that I'm going to have to stretch out. Let me do this. I need to stretch it out a bit because the classes are going to be quite big. This is what why I don't like the UML. You see how much time it's taking me to just do this thing because there's certain ordering and there's packages. Packages are the ones that ruin everything. If there wasn't a package, this thing of packaging, then would be done quicker. I also teach you some techniques there. That's why I said today is just only focused on um today is only focused on UML because there's quite a lot of things that can go wrong if you're trying to do your diagrams. But at least if you attempted it, you won't get a zero, which is kind of soothing because you know you're not gonna get a zero. It's better than nothing. So an enum type, right? Okay, in Java technically, right? In Java technically, let me think about it. Is it enum or interface? Is it an enum? Let me think about it. Enum. No, it's an interface. No. Yeah, it's an interface. So we don't represent an enum inside of our UML. You only represent interfaces and classes. Enum, remember, this is just constants. So it's not a class, it's just a constant. So it's just a type. Assume the person who's looking at the UML has access to your code, which is true because it's the assistants who are going to mark your code. So they can see your code. You don't have to put enums. Enums, you don't put them in your UML. Remember, UML is for modeling objects. An interface is a class. It's similar to an abstract class if you check your slides. So therefore, it counts as worthy to be put in a UML diagram. So we have two types of reduction areas, right? And you see extends, meaning inheritance. So let's start with active area, right? So I'm going to have active area. Yeah, let me add the class. So drag and drop a class diagram, and then active area. And then it has two things. It has, let me copy this type. It is deficit and effective type, right? So let's do that. So it has two active type, which is just called type. Okay, but then, okay, it doesn't matter in what order I declare them. It's actually fine. It doesn't matter in what order. You can start with the deficit or start with the active type. Deficit, which is of type double, and then it's private, right? Remember, don't click class scope. Class scope is for when it's static. None of this is static, so there's no need to select class scope. And then I'm going to rearrange them because I'm somewhat of a perfectionist, so I want it to be in the exact same order as it is in the code. If I started declaring deficit, I'm going to start declaring deficit in my UML too. It's just a preference. You don't have to do that. Then the constructor active area is another question. Can we omit constructors, accessors, and mutators as stipulated in the footnote on page 1? Oh yeah, my bad. Totally. But then it's fine. We can just continue. Yeah, you should omit them. Now I see because I was asking myself how will you finish everything? I remember they did state it somewhere. I was reading this document. Yeah. Constructors, basic operate do not need to be shown. So skip constructors, skip accessors and mutators. Right. But then toString, it's not an access, it's not a mutate. So you'd have to include it. So you can skip. If only I knew, I would have saved us a lot of time, but then it's too late. Let's continue with what we already have. I need to put in the full diagram so that you can see in the future for your future practicals. Because remember, you still do UML for other practicals. Is there another question? How do you give your package a name when using draw.io? I've been trying for a while. I don't use draw. I don't do draw for UML for diagrams. For diagrams like that, I only use draw.io for demonstrating what a variable is, that it's a box, stack, and heap. That's the only purpose. I don't even know draw.io like that. So that's why we use D. And you're not allowed to open Chrome, no data, no internet. Okay, you have internet, but you're not allowed to search other than anything other than Ulink or if. In this case, your comp sci students only if. If you are caught by any chance trying to draw.io, they might confiscate your paper. You're not allowed to use draw.io. They even told that to first years too. No draw.io. Use D. It should be there installed. If it's not installed, that's when you can raise your hand and ask. Don't just assume and do your own thing. Because trust me, they'll kick you out. Those people are heartless. They take your paper and say, come back next year. Don't do that to yourself. Or they'll kick you out, just take your student number and say you come back next year and fail you. Because clearly you're not following the rules and regulations for test venues. No, they are not allowed to copy in test venues. What counts as copied will be flagged. So you have to go study D. That's why we have this session so that you can follow on your own what I'm doing here. So the constructor is public. I know the constructor, it always takes in the first two parameters from my base class, followed by the other extra parameters in that child class or subclass. So the first two parameters for my base class, I know it's area ID, which is a string, followed by the word, which is a string. Oh, at least so you guys have time most to do the UML. Okay, I don't like the package stuff. That's the part that's gonna annoy you. The package stuff is the one that's the problem. Deficit, double, and then E active. No, this is the name of the variable. It's called type, E active type. You might ask yourself, why am I not referring to my code? Well, I know I'm the one who wrote the code. I know how I name exactly how I named the parameters. And you see, that's exactly how I named them. So I didn't have to go back and look at my code. And then we have accessors and mutators. We only have two variables, so it shouldn't take us too long. So let's create them because I want you to have a full UML. So we're gonna have, let's start with the deficit, right? So get deficit, which returns a double. Then we have set deficit, which returns a void, which takes in the parameter deficit of type double. Then we have a new one, new method operation, which is called get type, which returns an E active type. And then we have set type, which takes in a type, a variable of type E active type. And then obviously we're gonna have a toString here, so I'm gonna add that toString. Remember, we override the toString. So toString returns a string and then apply. Right, so that's the full class. And if you notice something, this class is gonna be similar to remember these are subclasses. They'll be similar to each other. So what I would do, right? I don't advise you doing that because you might forget to make the changes. I'll just copy and paste this class here and then simply rename it. Rename the constructor, change the parameters, delete the parameters that I have to remove because it's similar, right? So let me do passive area. So let's go to passive area. There's passive area. It has capacity. Oh, before I copy that, let me copy this class again. So we have these two. So let me put it down a bit so that when I do the lines, then it should be fine. So passive area. So passive, and then copy everything. And the attributes, remember we don't have this, we have capacity. So I need to delete that, create a new one. Capacity of type int, and it's private, and it's not a static one, so we leave class scope unselected. So it's a instance variable. So we don't click class scope. Then we rename our constructor to passive area because we're inside the passive area class. I know that after the word, the thing that comes after the word is the capacity. So I'm going to delete the last two, and then I add the extra third one, which is the capacity. So capacity. The type is int, and then apply. Then I remove all these getters and setters. Okay, I will not all of them. Let me just use one. And then create a getter and setter for capacity. So get capacity, which returns an integer, and then set capacity. And then it takes in a capacity, which is of type int. Yeah, that's okay, and then done. So you see that it's kind of a bit quicker if you copy and paste the same subclass and rename things. Kind of better than having to type everything from scratch. Yeah, so that's fine. Remember, this is a UML diagram, so you don't show, well, what is this? You don't show code. You only show the variables and functions. And then let's look at block schedule. It's also part of the same, what is part of the same, what do I want to say? Part of the same package. Yeah, so I need to create a block schedule class. So copy this. Yeah, okay, before you copy that, remember there's an array, there's a list of what? Reduction areas, right? So I need to actually put it somewhere here. So I'm gonna put it somewhere here. So that when I draw the lines, you see it's right next to reduction area. And this should be somewhere here. Put it a bit down. Yeah, leave it there. And then drag and drop a class diagram, double click, and then block schedule. All right, and then there's the class. Wait, we have an interface. Do we have an interface? No, we don't. But if you have an interface, you should also add your interface. Yeah, there's no interface. You need to also put your interface in the UML. Because remember, an interface is similar to a abstract base class, abstract class. Then we have a list of reduction areas and it's named areas. So as a attribute. So areas and the is type, it's list of reduction area. You can see that we have has a relationship, right? But we'll model that afterwards. Then we have a constructor, which is a no args constructor. So I'm gonna add that there. So go to my operations, no args constructor, create an accessor called get areas, which returns a list of the reduction areas. So list reduction area, and then apply to apply my changes. And then the other one is to add area. If I remember very well, I called it add area because I know I wrote my code. I'm the one who wrote the code, so I know what I wrote. I know what I wrote. These are not my marks. Some of you will be saying that for semester test 2 when it comes back. These are not my marks. I know what I wrote. Yeah, so we are done with the UML. So click OK. Right. Come on. Yeah, so let's think about the symbols, right? The relationships. So you see a reduction error, this type here, it's stored here as an instance, meaning block schedule has reduction areas or has a reduction area. So that means reduction area is inside of this. So that's why when it create the lines, the line is going to come from reduction area to block schedule because reduction area is inside of block schedule. So I'm going to copy this aggregation symbol. Like I said, it's vice versa. So I need to change this to face that side because this reduction area is the one that's contained inside here. Then I put this, then I align this. It's up to you whether you leave it as aggregation or composition, but I would most of the time choose composition. It's up to you. You can actually really think about it. Like think about it from a real world perspective. Should it be composition or aggregation? You can really think about it. That's up to you. I don't want to be using too much of my brain, too much time, too much effort, right? And think about this. I don't want to do that. To be honest, all these methods in the base class, you can make them protected technically. Yeah, but then remember we said you can just leave it as public because at the end of the day, we want the subclasses methods to be public. Since subclasses inherit from the base class, therefore it's only logical to make them public in the base class. So yeah, let's continue. Where's UML? So it's this diamond shape. So we click the diamond shape and then put here, diamond shape again, copy it, put it there. And then there we go. And then that's the inheritance, right? That's or generalization. If you check on D, it actually calls it same name, generalization, you see? It's either called generalization or class inheritance. You can use one of those terms. So we have that class. Let's check something here. So if we check these classes, right? Look at reduction area file handler. It returns a block schedule, but it's different, right? This relationship between a block schedule and a reduction area is somewhat of a different relationship. It's unique. Basically, they are what we call associated, meaning they just know about each other because it's not stored as a private as an instance variable or a class variable, which just simply means that they just know about each other. So in other words, they are associated to each other. So for that, use association, which is the symbol over here. Basically, two classes are associated with each other. So copy this and be very careful with the association diagram. Remember, I told you that I was going to teach you something about UML. I teach you a trick. If you drag that association symbol, right? I don't know why D does that. And you put it here. Basically, you paste it inside some package. Java expects it to only work within that package. You see, the arrow can't leave the package. That's a problem. So you need to paste it actually outside of any package. So copy, paste it here, outside of any package. Then you can put the arrows. So I'm going to put an arrow here, then put an arrow here, right? So it's up to you in what direction. I can double to change the direction. You can double click on the line. Then you can change the direction from A to B or from B to A. It's up to you. Meaning which one is associated with which one. So basically, in my case, right, reduction area file handler is the one that's associated with a block schedule. That's why the arrow this arrow here, right? This triangle. Let me zoom in a bit. That's why this triangle here, it's going to the block schedule because that class is the one that's associated, it's associated to that other class, not the other way, not vice versa. So I'm gonna leave that arrow in that direction, basically from A to B. If it was vice versa, then you just double click here and you change this from B to A and click apply. And notice the direction of the triangle, you see? It's moving in that way, meaning this block schedule is the one that's associated with the file handler, but that's not the case here. So I need to undo this. That's not the case. I'm just showing you an example so that you know all the tricks, you know how to change the direction if maybe that's in the practical, it's actually vice versa. So there's my UML, then I'm gonna go this side. We have another association again. Why? Because if you look at main, it knows about some class. Let's look at what it knows about. Basically, it means you've instantiated a reference type inside a function, some function. If you don't declare it as a class, as a instance variable, class variable, and you've used it inside a function, listen, you've used it inside a function, either to as a return type or instantiate it inside a function, we can say that that class is associated to that instance. In this case, I used a block schedule, meaning I am associated, the main class is associated with a block schedule. I also used passive, I also used active. So I'm associated with three classes, meaning I know about three classes, which is block schedule, passive area, and active area. Technically, you can say reduction area too, but then it's fine. You can just leave it to only passive area and block schedule. But reduction area was also listed. So that means we're gonna have a lot of associations here. So yeah, so and main is the one that's associated with those other classes. So the direction of the rectangle or triangle, I mean, will be going to that side, to the other, pointing to the other package. So it's associated to, okay, to make your life easier, right? And I don't, okay, let's not make it easier because that's not what is required here. We need to answer the question. So it's associated with this one. So I'm gonna put it here, right? It's associated with a active area, so it knows about active area. Yeah, it's fine. Let me do everything. Let me do all the associations. It's fine. It's also associated with a reduction area. So it's gonna, oh, remember you can't paste this inside a package. So paste the association on the empty space and then go here. Then this is associated with reduction area, meaning it knows about reduction area. Then I'm gonna minimize it again a little bit here so that we can have some space. So what's the last thing it's associated with? It's the active area. So copy this, paste it on empty space, point it to from main. It goes from main to, you should see, that's why I don't like UML. You see how I'm moving here. Now it's like kind of, it seems like, but it kind of looks like everything's all over the place now. You'll notice that. Ish, you see now. Hey, UML diagrams. Let me delete it. Let me actually make it move that in that direction. So it should go down like this, and then it travels down from here to there. Yeah, it's kind of annoying. So let me paste this on an empty outside a package. And then from here up to, let me put it under here. Yeah, like that. And then put this outside. Not, doesn't have to be outside. Yeah, you can leave it just here. Yeah, quite a diagram, right? That is quite a diagram, I'm not gonna lie to you. So you just need to understand association and inheritance, everything. Basically, you see that you're applying everything you taught this semester. Association, inheritance, aggregation or composition, um, public, private, protected. Yeah, learning everything, applying everything. So now I'm going to save this into, export it, right? What I would advise you, right? Okay, sometimes it might work, sometimes it might not work, but it's worth a try. I always advise you to save it as a SVG, meaning scalable vector image, right? Why do we choose that technique? Because when you zoom in, remember this is a big diagram, right? If you go back to this is a big diagram. They have to zoom in to be able to read what you've typed. So scalable vector image, when you zoom in, you don't lose the quality, meaning it's clear even when you zoom in. It's not like a PNG image which uses pixels, which means that the more you zoom in, it becomes what you call pixelated, meaning it loses quality the more you zoom in. So we need to use the SVG, which basically SVG, it uses mathematical functions to represent each pixel. So you can click, I think I moved a bit faster there. You can click on File and then go to Export because you want to export it. If you did commerce in high school, import, export, those terms. So here I want to export it, send it out, right? Then you can choose the file extension. Like I said, scalable vector graphics, SVG. So you click there, you're gonna click here, or you click this down arrow, whatever technique you wanna use. So you can click this down arrow like this, or you just click here like that to still show you pop-ups. Then you choose which file format you want. You would always choose Cairo PNG or Cairo SVG. Personally, I prefer SVG because it doesn't lose quality when you zoom in, which is what the tutors would have to do. You can also store JPEG. Where's JPEG? Yeah, I don't see JPEG. So like the proper JPEG, the ones I'm seeing is PixBuff. Maybe that's what's it called in full. Or you can also save it as just a normal PNG, right? I will save it as a Cairo scalable vector graphics. You can also just save it as a normal SVG. See, there's SVG here. There's a normal PNG. I will choose Cairo. That's just the preference. You can choose any. Then you give it a name. So let me give it a name and say the name of the image. So this will be 2024 ST2 Q1 UML, right? Then to make my life easier, I'm gonna save it on desktop. It's easy to find. I'm gonna click on desktop. Then I'm gonna click save. Then now if I go to desktop, I should see that file with the exact same name. There's the file. I think Edge, you can view the image in Edge. Yeah, in Edge you can view it. Let me talk. You see the scalable vector thing I was talking about. Look at when I zoom in. No quality is lost. They can see, oh, hash area ID, clear. If it was a PNG, it will basically it becomes blurry the more you zoom in. So it's sometimes hard to read words. So that's why I use scalable vector graphics, because it uses mathematical functions to represent each pixel. For my maths majors out there, this is a nice, interesting topic to go do research on. Basically, go learn about different image formats. There's a YouTube channel which actually teaches you the maths behind things. For example, the maths behind, for example, arrays, things like that. They can also teach you that. Or maths behind images, they also teach you that. So let's insert, we want to insert the image, right? But before you do that, right, remember before you do that, you need to write your details. So your surname, um, initials. It's up to you in what order. Let me just write it this way. Let me start by surname. Let's say my surname is Academy, right? And then my name or names, it can be one or more, is Vortex, right? Then the it's up to you, whatever you want to phrase, whatever you want, the headings you want to use. I can just say here, this is ST2 Q1 UML diagram. 2024, right? 2024 diagram, right? And then you keep pressing enter so that you leave there. Then you leave your cursor on an empty space. Because when you insert an image, it inserts it from the point where the cursor is. In this case, my cursor, see it's here. So it's going to paste the image starting from there going downward. Then I click on insert. Then I click on pictures. Then I click this device because I want to insert an image from my computer or from this device. Then I choose where I've saved it, which is desktop. That's why I saved it on desktop. You see, it's easier. If you check even the computer labs, right, even whether it's a foyer or at the foyer or D labs, the desktop is always empty. Or okay, let's do this. Remember, computers can switch off unpredictably at the venue. Save your SVG to the T drive. So I will demonstrate that in just now. So I've inserted my UML diagram. Done, right? Then I export. I'm going to go to File, and then I click Save As. Then I scroll down and click Browse because I want to save it. Or you can say click on this PC, and then but then this PC, you see, you have to understand a lot of things. Let's just choose Browse. Browse means that it's going to show me a pop-up and allow me to choose a folder. So I want to save it again to desktop, but then, like I said, don't save on desktop because your computer may switch off. So save it on T drive. So how do you find T drive? You go to this PC, or you can. Who's laughing now? Let me check something here. Um, just give me a quick second. Let me do this. Yeah, I've removed him from the meeting. Like I said, I'm not going to tolerate nonsense. You watch the recording. Don't have time for jokes. So let's go back here. So we want to save it to the T drive, right? So the T drive, how do you find the T drive? You go to this PC. You can either expand by clicking the greater than symbol. So click the greater than symbol. You see there's many drives here. So let me stretch this out. Here I only see C drive. So how do you know it's a drive? it is a capital letter and a colon. In this case, it's capital letter C and a colon. So this is what we call C drive. 4 is going to have a capital letter T. Then you click there, T drive. It will just be there somewhere here. Because what do you know why do you save it in the T drive? Remember, computers at UJ, when they restart, they delete all the files. If you've downloaded PDF, whatever, even your prec, your ST semester test 2, it will delete it if it restarts. Remember, Windows is unpredictable. It can out of the blue can be like Windows is updating. It shows that when that it loads that Windows is updating. So just to be careful, be careful about that. Make sure you save it on the T drive. Even your semester test 2 when you're creating the project inside Eclipse. So I'm gonna choose PDF because they want it in PDF. So I'm gonna click of save as, choose the save as type part. I want to save it as a PDF, so .pdf. Click there. Then you name it whatever. I don't know. I think you should name it according to the practical. Let me see. I would advise you name it according to the way you named your project. Let's scroll down. It should be somewhere here. Yeah. So say name this. So let's use this technique. To be honest, it doesn't really matter. You can just say design and then submit because you won't have time to do all of these things that I'm doing right now. Then paste. Then my student number is I'm just gonna put in a random number there. Then initials is it's Vortex or V. Say name Academy, right? Just as an example. So there's the PDF. Then I save it on the T drive. In this case, I'm saving it on the C drive. But then remember your project, your solution, right? For your answer for question 1 will be saved on the T drive. That means you have to look for it. Let's say this is the solution. I've saved it to the name MC64. You'd have to go inside that project, look for the docs folder, go in the docs folder, then save it. Click save. In my case, right, I don't have I didn't save. I was supposed to actually do that as an example, but you can do that once I don't see the need to over explain that. So I'm going to save my diagram to desktop just for easy access when I send it to you after the session. Then I click save. Then you should save your diagram and then bam, there's a diagram. Let me show you what I was talking about, the scalable vector thingy. You see that it looks kind of weird, right? You can't see, you can't read. But when you zoom in, notice something. No matter how much I zoom in, the quality doesn't disappear. It's easy to read. It's good quality because each pixel is represented as a mathematical function. Go research SVG files, right? Like SVG images. That's why it is the name vector, mathematics, right? Science related to that. Because each pixel is represented as a mathematical. Basically, you can view I can say it's a mathematical function, but also like a mathematical formula. Each pixel is a mathematical formula. By mathematical formula, like for example, f of x is equals to x squared. That's a mathematical formula, right? But then now I don't know what's the actual formula. You have to actually go. This is for this is for maths majors. You can go and do research on that. So this is how you do your design, right? And then once you're done here, you can simply leave. But don't make the mistake of leaving here and not making sure that you've saved. Because if you close here, it's gone. You have to start from scratch. So be very careful of that. What do I want to demonstrate? Okay, I can close this because I'm done. So there's the diagram. That's fine. I wanted to show you Eclipse, right? So let me go back to Eclipse. Remember, we talked about how to save the project on the C drive when you're solving question 1 and question 2. You go to File and then New Java Project as usual, right? The only difference is that you unselect default location because you don't want it to be saved in the default location. Trust me, you save it on a default location when the computer, for some weird reason, it says Windows is updating and then it restarts. Your prec is gone, like it never existed. It vanishes. It's not even in the bin folder. It's gone. It's nowhere to be found. It's settings that they put at UJ on those computers. So that's why they always advise you to save it on the T drive because even if it restarts on the T drive, when something that's saved on the T drive, it doesn't disappear. So you're gonna unselect this, then click browse. Then do the same thing that I told you. Go to this PC, expand it, then choose the T drive. Then to choose the T drive, just simply select it once like that. Then it's gonna show you here. Then for you, it's gonna show instead of C, capital C, it's gonna show capital T. Then just click select folder, and then you just click finish. But then don't forget to give your project a name and so forth. So that's very important. And then you zip and then you submit your code. So yeah, I think that's all we have to do. Yeah, that's all we have to do today. So yeah, that's the end of the session. We'll do paper two, right? We'll do the full paper at 8 p.m. tomorrow, at exactly 8 p.m. We'll do the full paper. It shouldn't take us 2 hours to do both questions because right now I'll be only focusing on the answers, not the explanations, because we already understand the explanations. So yeah, I'll send you this UML diagram. Oh yeah, I wanted to before we stop to go to YouTube. And then there's a channel called number file, right? For those who are interested in understanding how SVG file or images in general, what mathematics is used, all those things. There's this channel called number file. So it's about people who love maths or computer science even. For example, if you're interested in understanding arrays and things like that, you can use that channel. There's something called DNS and things like that. All those concepts are very important to understand if you want to know more about arrays. So this is the channel. Especially if you understand SVG, I'm sure they have. Or if you can't, then just go on Wikipedia or Google it. It's quite interesting. So that's it for today's tutorial. See you tomorrow. Yeah, tomorrow we'll just be doing paper two.